Hello, Greytons. Science Therapy. We are back again with Grade 10 Statistics. Now, looking at your screens, you have question 1 there. That is question 1 of paper 2. Now, question 1 reads, the heights of 20 children were measured in centimeters, and the results were recorded. The data collected is given in the table below. Now, the first thing to do when you are given a data set is for you to go and look at the data and confirm whether the data is in ascending order or it's random. If you find that your data is random, you have to arrange it in ascending order. That is, every time you need to arrange your data from the smallest value to the biggest value. Every time. Now, number 1.1 says, write down the median height measured. Now, you need to write down what is the median height measured. You need to write down what is the median height measured. Now, median, you will see it's defined down here on the video. So, without wasting time, for 1 mark, let us just write down what is the median. Okay, so you have an equation that might help you, or a formula that will help you identify where to find your median. So median is also known as the second quartile or quartile 2. Where there is n, you are going to replace with the number of values that you have. In this case, we are told that there are 20. So here the answer is 10.5. So this 10.5 is not your final answer. The 10.5 will only give you the position where you are going to get the answer. So this is position. So this is supposed to give you your position. Where is that position? You go to your data set, the data set that you're given. You start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember, it's 10.5, the position, which means you have to also include the next value, of which is 137. So writing your median, you would say median is equals to 136 plus 137. 136 plus 137 divided by 2. Now you will find that your median is 136.5. Now that is your median as it is defined. You will see there it is defined. We are going to define it for you. So now that's 1 mark for us for calculating for the median. Let's continue now to 1.2. Let's continue to 1.2. Now 1.2 wants us to determine the mean. Now mean is also defined in the video here, as you can see. Now the mean, remember, mathematically is represented like this as an x bar, and it's the sum of all values divided by the number of values. So this is going to be equals to, if you add all the values, you will find that they add up to 2,728. And how many are the values here? The values are 20. We have 20 values. So the mean in this case is 136.4. Let me just write it clearly so that everyone can see. So it's 136.4 centimeters. Centimeters, remember, they said it was measured in centimeters. It's important to show the SI unit. Okay, we are done with the mean. We do understand. Another word for the mean might be average. You might be familiar with calculating the average. So maybe sometimes when you forget what is the mean, just remember it's the average. Okay, so let us continue from 1.2.2. Now remember, we are now asked to calculate for the range. What is the range? The range is the maximum value subtracting the minimum value in your data set. So in this case, looking at our data set, our maximum value is 145 and the minimum value is 127. So we are going to calculate for the range. So you would say range is equals to maximum value minus minimum value. And our maximum value is 145. You subtract 127. Your answer is 18 centimeters. So this is the range. Now the next question, 1.2.3, is looking for the interquartile range. So this is the range of the quartiles. Now let us go back here and I want to show you something. Remember, I showed you the equation for finding the position for the median. Now we said Q2 is equals to 1 over 2 n plus 1. Now this is for the second quartile or the median. Now if you want to find Q1 and Q3, they have their own formulas. So for Q1, it's 1 over 4 n plus 1. So 1 over 4, what is n? It's the number of values that you have in your data set. And we are told that they are 20. So it's 1 over 4 n plus 1. You will punch it in your calculator here. Now you come back here. If you're looking for Q3 again, it's 3 over 4 n plus 1, which is equals to 3 over 4, 20 plus 1. Now the values that you get here are not your actual Q1 and Q3, but rather they represent your positions. These values represent the positions. They are going to direct you straight to where you are going. So remember here, the answer that you will get is 5.25, and the answer that you will get here is let me just punch my calculator real quick, 15.75. Now these are positions. These are not your answers. These are not your actual answers. Remember, I just wrote Q1 just to reference that. In order for you to get the position of Q1, you use this formula. In order for you to get the position of Q3, you use this formula, not actually the answer. So we are told that we will find our Q1 at 5.25. And bearing in mind that our data set is even, so which means if we find Q1, it won't just be one value. It will have to be two values that we'll have to add them together and then divide by 2. Same applies as Q3. All the quartiles in this case, if you have an even number representing your data set, this will be the case. You'll have to take 2 terms and then add them together, then divide by 2. Always remember that. So let's go to our data set there and locate 5.25. Let's look. It's 1, 2, 3, 4, 5. Remember, it's not just 5. We'll have to take both these terms, 131 and 133, and then add them together, then divide by 2. So let's just do it in a clear place. So remember, here we are dealing with 1.2.3. So 1.2.3 here. 5.5, it would be for Q1 would be 131 plus 132 divide by 1. Oh, I mean it's 133. Sorry, I didn't really check nicely there. Divided by 2, and it's going to give us 132. So our lower quartile is 132. Now let us find our upper quartile. It said that we must find it at 15.75. Let's quickly go there to 15.75. So it's 141 and 142. So we'll have to add them together, then divide it by 2. So let's go back again. For Q3, it's 141 plus 142. 141 plus 142 divided by 2, that gives you 141.5. Now these are our quartiles, Q1 and Q3. So in order for you to find the interquartile range, this is what you do. Write this. Let's continue here. So for your IQR, you will say it's Q3 minus Q1, and that will give you 141.5 minus 132, of which is equals to 9.5 centimeters. So that's your IQR. Now, it's a very simple and straightforward step. Number 1, find the positions. Go and read the positions. Add the numbers, divide by 2 if the data set is even. But if it's odd, it's different. You will just have to take the specific value that your position will be telling you to find the value at. Let's now do 1.3. Drawing a box and whisker diagram. Remember, a box and whisker diagram represents 5 main key points or key values: the minimum value, the first quartile, the second quartile, the third quartile, and your maximum value. So how do you really represent this? I'm gonna need a space here, so I'll have to scroll down and I will start writing from here. This is your 1.3, the box and whisker diagram. Now, first things first, you need to have your perfect number line. Obviously, you'll be using a ruler, not like me. So you can have a number line. Since our data set begins at 127, we can just do a scale of 5 and begin it at 125 here. And then the next one would be 130, 135, 140, 145. Maybe we can say 150, but it's not necessary because our data ends at 145. Remember, this is our maximum. Our maximum is 145. So what do you need to represent? You need to represent your minimum. Your minimum is 127. So right here could be our 127. Remember, it's a sketch. It's not drawn to scale. And our Q1 in this case is 132. So we'll go from here, we go like this, and we assume that our 132 is somewhere around here. So that's where we are going to draw our first line of our box that will be representing our Q1, and then we continue like this. Now we need to represent Q2. Remember, Q2 is 136.5. So it's somewhere around here. Remember, our diagram is not drawn to scale, but it must be drawn to scale for you because you'll be using a ruler and a perfect scale. So you'll be measuring perfectly where your 136.5 could be. So we assume that our 136.5 is here. Now we head on to our Q3, of which is at 141.5, of which could be somewhere here. So our last line to close off the whole box will be right there at 141.5. So remember, it's very important for you to indicate what these values are. You don't just draw a dot. So you have to tell us that this is at 127, and you also have to tell us that this here is at 132, and here it's at 136, 141.5, and here it's at 141.5. And the last value that you need to represent right now is your maximum. So you go there and do like this, and voila, you've drawn your box and whisker diagram. So highlight on drawing the box and whisker diagram. You are representing 5 numbers. It's also known as the 5-number summary box, or the 5-number summary, full stop. So it represents your minimum, your Q1, your Q2, your Q3, and your maximum value. So these are the 5-number summary. So whenever you are asked to draw for a box and whisker diagram, remember, start with your number line, scale it perfectly, and then represent the values accordingly, as you can see. Thank you.